Hi, I'm Victor Fuentes. I work for Cross in Germany, in Munich, and I want to play. Head or tail? What are the odds to get a tail? Yes, 1/2 or 0.5. One outcome over 2 possible. What happens if I toss again? What are the odds to get again a tail? If I do exactly the same again and again, shall I get the same outcome? No, because it's impossible to repeat exactly the same experiment. Let's introduce this and see how it plays out in online marketing. We can calculate the probability of a specific outcome in an experiment, and we also use probabilistic predictions to use an outcome in an experiment in a stochastic process, which have a random or unknown variables. The point is, since it's absolutely impossible to identify all the conditions and elements involved in the experiment, we consider tossing a coin like a random result experiment. That's nice for gambling, but what about online marketing? I can extend the previous conclusion to online marketing. Online marketing is like bet for a specific outcome and see what the result will be. We know practically all the conditions and elements that play in online marketing, but it's absolutely impossible to identify, quantify, and measure all of them. All of them. That is why we consider online marketing as a stochastic process. If we want to know if the odds are in our favor when we make decisions, or we want to know what the probabilities of getting a specific outcome are, given some initial conditions, we need to have a kind of tool to predict the results. Suppose we want to make a prediction about a user behavior while browsing in the internet in order to personalize the web page content. Due to a variety of different reasons, it's impossible to determine all the variables involved in the process, so we can expect a lot of randomness on the possible choices the user makes. What I need to introduce now is a mathematical model, a simplification of it. A mathematical model is a kind of a numerical machinery that, given an input, calculates an output which, with more or less accuracy, explains some process, fact, behavior, etc. In this example, a model will describe how the user browses on a specific web page, and we will use it to make a prediction for a simple scenario. Given a user browsing on one web page, which web page will be the next the user clicks? In this example, we will eliminate the time variable, which means that our model doesn't take into account how much time the user spends on each web page. Our mathematical model is called Markov chain, precisely finite states Markov chain. There are several variations of the Markov chains, but for our purpose, we can define a Markov chain as a limited sequence of different states where the transitions between states are done randomly. The important part of this approach is each transition from one state to other could be predicted by a probability. In the first order Markov chain, we consider the probability of transition from one state to the next is given only by the previous state. For example, from state B, it's possible to go, that is, to make a transition to state C or to state D, and each transition has a probability given and influenced only by the previous state A. Okay, we have a model, a Markov chain, which helps to predict the transition from one state to other by a probability. But how do we calculate those probabilities? Looking for similarities with the tossing experiment introduced previously, the precise question is, which ones are the experiments we have to do to calculate those probabilities? Basically, how can we fit our model, the finite state Markov chain, with real data? Possibly, that is the most complicated task when applying mathematical to online marketing. Identify and collect the rich data to fit the model. Simplify it. What we have to do is collect data from users browsing over the web. With all this data, we build a function where we assign a number, a probability, based on real data, to each transition existing on the different possible sequences. Seems easy. We have a mathematical model called first order finite state Markov chain. We can collect data to fit it and calculate some probabilities. So, can we predict with accuracy the next user web page choice? If our user were perfect, possibly. But not only the user, but the process are very complex. For example, what happens if our user has two browsers open and he or she is browsing simultaneously with both? Exactly, complex, right? What I try to do is unveil how it's possible to apply mathematical models to understand better what happens in online marketing in order to make accurate predictions and bet as safely as possible. Betting as safely as possible is the maximum you can achieve in online marketing because, just like with the coin toss, there is always randomness in the real world. Thanks for listening and goodbye.